Welcome to problem number 8 in the problem solver playlist of Science Lecture Theatre. I am your lecturer, Professor E.O. Efa. The problem: the random variables x and y have joint probability function given by f of xy is equal to 2 over n into n plus 1 for x going from 1 to n and y from 1 to k, and f of xy equal to 0 elsewhere. Find the value of k that will make x and y independent variables. Pause the video and try the problem on your own. You need help? Then continue watching. Solution: we know that two discrete random variables x and y are said to be independent if their joint probability function f of xy is equal to the product of their marginal probability functions f of x times f of y, where the marginal probability function f of x is equal to sum of f of xy over all possible values of y. This is equal to sum of 2 over n into n plus 1 for y going from 1 to k. Since this function 2 all over n into n plus 1 is a constant function with respect to y, so when we sum this as y goes from 1 to k, that will give us 2k all over n into n plus 1. Also, the marginal probability function f of y is equal to sum of f of xy over all possible values of x, and this is equal to sum of 2 all over n into n plus 1 as x goes from 1 to n. Again, with respect to x, this is a constant, so when we sum as x goes from 1 to n, this will give us 2n all over n into n plus 1. This n will cancel this n to give us 2 all over n plus 1. So therefore, the joint probability function f of xy, which is equal to f of x times f of y, implies 2 all over n into n plus 1 is equal to 2k all over n into n plus 1 times 2 all over n plus 1. Now, solving this equation for k, we obtain k equals to n plus 1 all over 2. And this is true for any odd integer n. Since our k must be an integer, for n plus 1 all over 2 to be an integer, n must be an odd integer. We have come to the end of problem number 8. Thank you for watching, and keep on watching. I remain your lecturer, Professor E.O. Efa.